Okay, so here is our yield of our copper 1 ions. Here you can see a little glisten to it. Doesn't look like very much, and that's because it's not. I specifically just didn't make very much because I don't really have a use for it, and also I did not have very much ascorbic acid to use. So had I had more ascorbic acid, I could have made more, so that limited what I had to do. But as I said, there's no real use for it at this point in time. I mean, I'll use it at some point in the future. So this is drying right now, and then once it gets relatively dry, I'm gonna weigh it, and we'll see what we got as far as yield goes, because I know the starting materials what I used anyhow, so we'll figure that out. So something that you need to know about copper 1 is that it will, if left unchecked in regular atmosphere, it will oxidize into the copper 2 eventually. So care needs to be taken to store it and dry it in an inert atmosphere as much as possible. And so I know for the home chemist that can be a challenge trying to find argon or you know, some kind of a noble gas. And so I have found kind of a way to circumvent that. And so there's two things that I use. Most commonly I use propane, and butane I can also use sometimes, but it's just a lot easier to use propane. And what I use is I just have my little bernzomatic torch here. And so you can see here I've got my copper oxide sitting in a bag on the plate there. And so what I'm going to do is I'm going to actually just crank this on without lighting it and fill up the bag with some propane, get it basically you know, full enough that it knocks all the air out, and it's just propane in there, and I'll seal it up. And what I'm also going to do is I'm going to use the bag as a desiccator. And so right here, what I've done is I've got a bunch of these little containers. They're all the same size, and so I cut the top off of them. There used to be a screw lid on it, and you can see what I did around the rim. I kind of just put notches the whole way around it. And so what that does is when the bag hits the top of it like this, you can see what happens. It would seal right there, but now you've got these notches, so it allows air to get through there. So if the bag ends up falling on top, then you don't have a problem. So anyhow, so this is full of some sodium hydroxide. I'm going to throw this in there in the bag, and I'll pump some propane in there and zipper shut. So you guys need to be aware that if you're going to do this, you should dry and store it in an inert environment. And propane and butane are by far the best ways to go, at least for the amateur chemist, in my opinion anyhow. It's the best thing I've found. If you don't have a tank of argon or xenon or something laying around, or neon. So there we go. I got the bag zipped mostly closed. Push all the air out of it that I can. And so now let's crack on Mr. Bernzo. Get him in the bag first so we don't waste any of our propane. Oh no. Oh, there we go. Thought I was out for a minute, but help if I would crank it the right way. And so I never actually even realized that propane, I should have assumed as much, was an inert gas until I actually went to make a forge. And I was making the forge myself out of a 20-pound propane cylinder. And lo and behold, when I cracked it open, I found that the entire interior of the propane canister was just pristine. And I'm like, whoa, sweet. So, yeah, so that's how I learned that propane was an inert gas. And so then by default, butane is right in there too. And those are, just the easiest two to come by for OTC chemistry.